Hello guys, and welcome to another engineering mathematics exam review session. So we are going to be answering a question on curve fitting. Now, if this is your first time of visiting my channel and you're looking forward to past questions, I have already created tons of examples and past questions, so to say, on engineering mathematics. Some of the questions that you are most likely to encounter during an exam scenario. Now check my playlist and you will see that I have segmented the topics in mathematics, engine 307, and there is also engine 308 for second semester. So please like this video right now and subscribe to my channel to stay updated. So as you are doing that, let's dive into the solution of this problem. Now, before I go further into the solution of this problem, I decided to break it down so that the video will not be too long. I'm just going to solve question 4a in this video. Then in the next video, I'll solve question 4b. But in question 4a, I want to teach you how you can arrange each of the following to give a straight line graph. So let's dive into the solution of each of them. So how can you arrange each of the following to give a straight line graph? Okay, so let's begin. Solution. And if this is your first time of watching my videos, I usually draw a solution and I attach a bulb close to it, not because I graduated as an electrical electronic engineering student, but I just use this to depict that solution comes when there is light. So when you have light, when you have that spark, okay, then solution comes. So I wish you the best in your exams and hope that you get the spark to solve your questions appropriately. Now let's dive into the solution from the first one. Now I want to tell you that you're dealing with a straight line here, okay, and everybody at this point should know the equation of a straight line. Y is equal to mx plus c. Okay, so m is for slope and c is for intercept. So if you know this thing about a straight line, then you're safe. So what they want us to do is to try to represent each and every of these equations given above in such a way that it will be in a straight line form. Okay, so this is what I'm going to advise you to use. Use this particular pattern. So something is equal to slope times something, okay, plus intercept. Okay, let me just make it general. Plus or minus slope, then plus or minus intercept. So I want you to use this general format, okay, when you want to answer these questions. So something is equal to plus or minus slope times something, then plus or minus intercept. And I'm going to explain it for you, because when you are doing some modifications to each and every of these equations, it must not always be y here and it must not always be x here. Okay, but two things must stand. Okay, there's a slope that must be here and there is an intercept that must be here. So I put a plus or minus to tell you that it's not always going to be positive. Okay, sometimes it will be negative. So I put a plus or minus slope here to tell you the same thing. The final slope that you get after you change the nature of this equation will not always be positive. Sometimes it will be negative. So with this in mind, let's see how we are going to solve the first one. I'm going to show you how you should write it and present it in exams so that you can score your 2 perfect points. So the first one says that we should rearrange y is equal to ax squared plus b. Y is equal to ax squared plus b. Okay, this one is already looking like something is equal to slope something, okay, then plus b. So the something is the variable on this side and something is the variable on this side. So my slope and my intercept are intact. So for this one, we can leave it like that. So what you're just going to do is you're just going to draw a graph, a short graph like this. Okay, so on the y-axis you're going to plot y, okay, for your dependent variable. Then on the x-axis you're going to plot x squared. Okay, you're not going to plot x, rather you plot x squared. So when you when you do this depiction under this particular one, you're going to call your slope A and call your intercept B, and that is all for this one. So that is how you're going to represent this one in a straight line. So what the markers want to see is what you have on the y-axis and what you have on the x-axis. So the y-axis, you're going to replace it as y, and the x-axis, you're going to replace it as capital X squared. So some people can say capital Y is equal to A capital X plus B. So if they plot the graph like this, capital Y will be equal to Y capital X will be equal to X squared. Okay, some people can do their own like this. Okay, so I'll just go ahead and do my own like this so that yeah, they will understand. Okay, so no need of capital Y and capital X, but I'll come back to the use of the capital Y and the capital X later. So we just want to see this variable here and this variable here. Okay, so I hope you get the gist. So you can pause the video and try to do the remaining ones by yourself. So once you're done, you can unpause it and see how I solved them. So 1, 2, go. All right, welcome back. So let's see how we can solve the rest, and let's see if we got them correctly. So let's go to the second one. Y is equal to AX plus B. So in the second one, we have Y is equal to AX plus B. So this one looks pretty much intact. We just need to draw our graph. Our y-axis is equal to Y, nothing to change. Our x-axis is equal to X. Okay, so you plot Y on the y-axis and you plot X on the x-axis. So your slope is going to be A and your intercept is going to be B. Is that okay? So you plot Y on the y-axis and you plot X on the x-axis, unlike the one above where we had to plot Y on the y-axis and on the x-axis we plotted X squared. Is that okay? So that is all for this second one. So let's go to the third one. Third one is Y is equal to A over X plus B. Y equal to A over X plus B. So you have Y is equal to A over X plus B. So if Y is equal to A over X plus B, so this one is straightforward. There are different ways of solving it. Okay, everybody must not get the same answer, but the most important thing is how well you label it. Okay, so I'm going to show you two ways of solving this one. So way one, I'll use way one here, and I'm going to use way two here. Sorry, way two. Okay, so both of them are still correct. Now, in way one, someone will just decide to plot this equation like this. So on the y-axis, he will decide to plot y. On the x-axis, he will decide to plot 1 over x. Okay, so the slope will still remain A and the intercept will remain B. Will be B. So someone will decide to plot it like this, okay? Because the idea is that y is equal to A bracket 1 over x and plus B. So if you use a capital Y is equal to A capital X plus B, you discover that your capital Y is equal to Y and your capital X is equal to 1 over X. Is that okay? And you can write it like this. Way two, someone else would decide to change this equation by multiplying through by x. If you multiply through by x, you get xy is equal to A plus bx. You can rearrange it by saying xy is equal to bx plus A. Now you can have something is equal to slope something plus intercept, okay? So in this case, if you choose to solve it in this form, then you're going to put your graph like this. So on the x-axis, everybody will agree that we can plot x, but on the y-axis, you're going to plot xy, the product of all x and y variables. In this case, your slope will transform to B and your intercept will transform to A. Is that okay? So whatever you plot as xy comma x, when you draw the straight line or you draw the curve involved, if you calculate the slope, it will be equal to B, and the intercept, wherever the curve cuts the y-axis, that's the xy axis, to be A. I'm not talking about the y-axis again because we've converted this variable to xy. So I hope you guys are feeling the solution. You're feeling me, right? Okay, so let's go to 4. So you have y is equal to ax squared plus bx. So in problem 4IV, y is equal to ax squared plus bx. So the approach to solve this one is, remember, you want something is equal to slope something plus intercept. Okay, you always want this intercept to be free. So I'll start with this point b. Since I want it to be free, I'll divide through by x. So divide through by x. Dividing through by x, I'll get y over x is equal to a. When you cancel out one x squared, you with one x, you just be left with ax, and you have b over here. Is that okay? So you can see now that we have something is equal to slope something plus our intercept. So in this case, we could decide to plot our axis as follows. So the y-axis will be changed to the y over x axis, then the x-axis will remain as the x-axis. So under these circumstances, our slope, any curve that we plot and we calculate the slope, it will be designated as a, while the intercept will still remain as b. Okay, so this is the transformation that we are talking about. Okay, so that's the solution to this one. So let's look at the last one. So the last one is y is equal to a divided by x plus b. So y, that's the last one, y is equal to a divided by x plus b. So who can tell us what we'll do in this one? Very good. So we can decide to take the reciprocal, right? So actually there are different ways of doing it. So way one is, if I take the reciprocal both sides, okay, taking the reciprocal of both sides will give me 1 over y is equal to x plus b divided by a. And by the principle of additive distribution of fractions, so you have 1 over y is equal to you have x over a plus b over a. Okay, so you can see now at this point, you can still see this as 1 over y is equal to 1 over a, then x, then plus b over a. So at this point, you can have your axis arranged this way. Now the x-axis will remain as x, but the y-axis will change to 1 over y. So instead of you to plot all values of y, you'll be plotting all values of 1 over y in the y-axis. Is that okay? Now in this case, there is a difference because your slope is now going to be 1 over a, the inverse of a, and your intercept is going to be b over a. Is that okay? So take note. So any graph that you get, or any curve that you get by plotting 1 over y versus x, the slope of that graph will be equal to 1 over a, and the intercept on the y-axis, on the 1 over y-axis, sorry, is going to be equal to b over a. Is that okay? So the second way someone would have solved this same problem and gotten the answer, way 2, okay, is, let's say you are given y is equal to a plus x plus b. You can decide to cross multiply, giving you y into x plus b is equal to a. So at this point, you distribute, you get xy plus by is equal to a. So if you do the math, rearranging it, you get xy is equal to negative by plus a. Now someone else would have solved his own like this, and he would decide to plot his graph as follows. So on the y-axis, he would change the y-axis to the xy axis, okay, while he would change the x-axis to y. Man, this is so crazy. Or he can change the x-axis to minus y. That's very crazy, changing the x-axis to minus y. If you change the x-axis to minus y, you will have b of minus y plus a. In that case, your slope will be b, okay, and your intercept will be a. But If we decide not to do it this way because of too much complications, and let me just wipe this one away. I don't want it to be the minus y-axis. I want it to be just the y-axis. Okay, so if I leave it in this form, then I'll have my x-axis as values of y, my y-axis as values of xy, then my slope will now be minus b and my intercept will be a. So I hope you appreciate this. So as many as they give you, as many as they give you, you should be able to know how to transform it into a pattern that you can be able to, you know, call a straight line form. Okay, let me just try to think of another one. Sometimes it might involve exponentials too. Okay, it might involve exponentials, for instance. Let me just come up with something. I know it's been long, but let's assume you were given something like y is equal to exponential, let's say ax. Okay, so y is equal to exponential ax, let's say, plus b, for instance. So let's say they ask you to convert this particular equation. Okay, they ask you to convert this particular equation to straight line form. So convert to straight line. So if they ask you to convert something like this to straight line form, remember straight line form is something is equal to slope something then plus intercept. Okay, so that's what we want to do, but in this case we have exponentials. So if we have exponentials here, we have to be very careful. Is that okay? So what I'm going to do is I'm going to take the natural logarithm of both sides. Okay, because I want to split this one to straight line form. Forget, because this one is in straight line form, it doesn't mean that automatically this is a straight line. No, it's not yet in a straight line form, it's in an exponential form. So to convert it to something that looks like a straight line form, I'll take the natural log of both sides. Thanks to men like John Napier, who invented the natural logarithm symbol. So you can read more about that if you're a math enthusiast like me. So we have to take the natural log. That's natural logarithm ln y is equal to ln exponential ax plus b. Now there is a property in mathematics that ln f of x is equal to, ln natural logarithm of exponential f is equal to f. Okay, so natural logarithm of exponential f is equal to f. This property belongs to the general property in maths that a function taking the value of its inverse as a parameter, f inverse or f of f inverse of x, it's going to give you x. Okay, so or f inverse of f of x is going to give you x. So this is an important property in mathematics. The ln function, the natural logarithm function, and the exponential function, they are inverse of each other. So when you take the natural logarithm of exponential of something, you get that stuff. Or if you take exponential natural logarithm of something, you're going to get f. So it works both ways. So with that explanation in mind, ln y is equal to ln e to the ax plus b gives me ln y is equal to ax plus b. So have you seen how we have transformed this one into something is equal to something x plus something? So if I want to plot this one on the y-axis and on the x-axis, instead of me to plot values of y, I'll plot the values of natural logarithm of y. While on the x-axis, I'll still retain values of x. Then the slope will be attributed to a, and the intercept will be attributed to b. So if you've come this far, this is the end of the video, and in the next one, I'm going to show you how to solve problems using method of least squares. So we're going to be pretty fast about that so that you can know how to apply, intuitive methods to solving your exam problems. Now, if they give a question on curve fitting, do not afford to miss it, because that's like a bonus question. Curve fitting is like the simplest out of all the engineering math questions that you should expect. So I'll expect you to solve that one gracefully and get your marks. That is why you should subscribe and watch out for the next video, which is going to be using the method of least squares to solve for the line of best fit for a particular data. Okay, so for those of you that want to go into data analytics and machine learning and artificial intelligence, you have to understand that the method of least squares is also related to regression analysis, where you have to train a machine learning model to be able to understand data and to be able to predict data. So the basics of understanding machine learning is your ability to understand simple method of least squares in statistics and engineering mathematics. So hopefully you stick to my channel, you have a lot to benefit. So thank you for watching. Stay tuned until the next video.